All right, folks, chemistry, let's do this. We've got the next section of notes to work on. So we are going to be talking about electrons now. So far we've mostly been talking again about the atom in general. We've been focusing a lot on mass, atomic mass, which is really nothing to do with electrons. Electrons have mass, but they're tiny. However, electrons are the most important part of the atom, at least from a chemist's perspective, because they're the ones that are involved in bonding and chemical reactions. So we're going to start talking about those. So let's just take a quick look at your notes. So far we have done this first part. I didn't write everything in, but I know that you have. That's good. Okay, so we've got the periodic table, atomic structure, and atoms. We also have kind of talked about isotopes a little bit and average atomic mass at this point. So now we need to start talking about electrons. So let me show you all. So we're going to be filling in for this, we're going to be filling in this section. I'm going to show you some slides. You're going to need like a model. So like kind of like some concentric circles. I'll show you what it should look like in the ends, and then we'll go through it so you know how much space you need. You're going to need like a little staircase here, and then one sample. At the end of this, your assignment is going to be in the unit packet, page 3, these 4 bottom sections. Okay, so these 4 are that's your assignment that goes along with this. So let's get into the PowerPoint so you can see exactly what we're doing. Okay. I am also going to post some videos for you that kind of talk more about electrons. There's some really great like TED Ed animated videos that are super awesome. Gotta drink some water, it's hot. It's Tucson in the summer. Okay, so these are some models of the atom, a history of the models of the atom. So over time, as people started learning more and developing more tools and math and like just physical like objects and technology, we've started to learn more and more about the atom. I like to think of it as coming into focus. So back in the early days, John Dalton, who looks like Harry Potter, he kind of thought of atoms as solid spheres, which was really a good start. Over time, scientists started recognizing that there were different particles. They first kind of discovered electrons, and then knew that atoms, though, were overall had a neutral charge. There must be something to counterbalance that. So we get the J.J. Thomson plum pudding model. It's also known as like the chocolate chip cookie model. And then that got kind of revamped a bit with Ernest Rutherford, who discovered that mostly atoms are made of empty space with this kind of dense positive nucleus in the middle, and then electrons on the outside. Somewhere in this time, they discovered protons, probably around the Niels Bohr time. Neutrons were the last particle to be discovered. I don't remember exactly when, but there you go. So Bohr came up with this model where talking about how electrons are not really, they're not just kind of static, like in this plum pudding model. They don't orbit in these perfect ways like planets either, and it's not super random. Instead, there's these energy levels, kind of like an onion. So there's like shells. Some electrons are in the very close areas and some are further out. And then also electrons don't really exist in between those energy levels. They're kind of on those rings. This model is also a little bit deceptive because it's not like a planet. This is also known as like a planet, kind of similar to a planetary model. Electrons aren't like that. It's a lot more like the Schrodinger model, which is what we call the quantum mechanical model, where electrons they're not really particles. There are particles, but they're also not particles. This is where physics gets a little funky. It's really cool stuff, but it's beyond the scope of this class. They sort of exist in area probabilities. Again, there's a TED Ed video that you should check out that's related to that. So what we're going to be doing today, we are going to focus on this Bohr model of the electrons because it works pretty well for most of what we need to do. Second semester, when we get to the bonding unit, which is going to be, it's unit, oh gosh, I think it's unit 7. That sounds about right. Unit 7, that's the second unit that we'll do second semester. We're actually going to do unit 1 first. No, we'll do unit 1 after. So unit 7 is the first unit that we'll do second semester. We're going to get more into this. There's more details to be learned from this that are really interesting, but we don't have to worry about it yet. So I love this graphic. I just wanted to show it to you. It's very beautiful. It sums up lots of stuff. There are also videos about the history of the atomic model that are also posted in the playlist. And I will even link those and maybe make like a Teams post or something like that about this. Okay, so here we go. So we're going to talk about this whole Bohr model thing. And this is the area where you're going to write stuff. So here's what you need to know. Electrons occupy shells or orbitals. We can use those interchangeably. And there's the first shell, second shell, third shell, fourth shell, fifth shell, and I think it goes up to 6 shells. Maybe 7? Let me check. It's actually in our periodic table. It goes up to 7. So there's 7 energy shells where all electrons exist. And there is a rules and order about how they go, how they fit. And that's what this Bohr model is all about. So I want to show you the last slide just so you know. Okay, so this is a great example of a Bohr model. I'm going to come right back to it. I just want you to see what your notes are going to look like. This is all the stuff you're going to be writing down. So however much space you have on your sheet, leave enough space for the circle, the big circle, this big one, the little ladder, and then one example. Okay, so you need to kind of separate this up into 3 sections. All right, so I trust that you have done that. And let me go back. Okay, so electrons are negative and the nucleus is positive. And what we know about atoms is that they're kind of like magnets in that the opposites attract. So the electrons are super attracted to the nucleus. They want to be as close to the nucleus as possible. But what Bohr and Niels Bohr and a bunch of other scientists of this time, including Schrödinger, including Maxwell, there's like a whole slew of them. Einstein was sort of vaguely involved in this as well. Not really, but kinda. Heisenberg for sure. Schrödinger, I forgot Heisenberg's first name. Anyway, that's where Walter White got his nickname. He calls himself Heisenberg. It's from an actual scientist. Yeah, the Heisenberg uncertainty principle, pretty cool stuff. Anyway, they figured out that not all electrons can be as close to the nucleus as possible. There's only a certain number that can fill up. And as you go out, there's more and more and more space. But you always start in the center. You fill up those shells or orbitals really close to the center first. So you end up with a model that looks something like this. Okay. This is the nucleus. This is potassium. That's what K stands for. It's because of the Latin kalium. So potassium is in the middle. And there's a first shell is here. Let me actually grab my, where can I want to draw, but what if I want to write things? What if I want to annotate? Oh dear. It doesn't want me to annotate. Oh, well, that's okay, no problem. So this first shell only can hold 2 electrons. The second shell can hold 8. The next shell looks like it is also holding 8. And then you've got this outer shell that holds 1. This is not 100% true. The next shell actually, I think, can't the third shell hold more? Nope, the third shell also only holds 8. I think it's 10, whatever, we'll get into it. Anyway, this is the basic model. As you get to bigger and smaller, different sized elements, your periodic table, like on your periodic table, you just kind of keep adding them onto more rings. Okay, so let's go through how this works. So this blue dot represents the nucleus. It's positively charged. The first shell can hold 2 electrons. So this could represent helium. So helium has 2 electrons if it's neutral, because it also has 2 protons. So if an atom is neutral, it has the same number of protons and electrons because they have to balance each other out. If it had an extra electron, it would be -1 charge. If it was missing an electron, it'd be +1 charge. So hydrogen and helium both look similar to this. Hydrogen only has 1 electron. Excuse me, helium has 2. That's just in the first shell. I think of this like a ladder, or like, not like a ladder, like a set of stairs. You can't exist in between stairs. You're either on a step or you're on a different step. There's no, it's not like a slope where you could be at any point on it. So if you have more electrons, let's just say we have an atom of lithium or beryllium. Beryllium has 4 electrons total. So the first 2 electrons would go here. Then you have to move up to the next level. Now, this second shell or second orbital can hold up to 8, but it doesn't have to hold up to 8. It could hold just 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8, depending on how many electrons. So if you are looking at, let's just say nitrogen, for example, nitrogen has 7 total electrons because it has 7 protons because its atomic number is 7. In that case, the first 2 electrons would go here in the first energy level. Then you have 5 electrons left, so they would go on the next shell. So it wouldn't look quite like this. It would look like this, but you take away like 1, 2, 3 electrons, and that would be nitrogen. Okay. Well, now we have a total of 10 because 8 plus 2 is 10. But what if we have more electrons? Well, we got to go to the third level. The third level can actually, oh yeah, it totally can hold up to 18. That's why I remember now. Yeah, it can hold up to 18. So we now have 28 electrons. So if you have an element that has anywhere between 8 or 10 and 28 electrons, you're going to need that third shell. It might not be completely full. It might only have 1 electron or 5 electrons or 2 or 12, but it could hold up to 18 if you needed it to. So again, you can't have electrons halfway, like in any of these halfway zones. They're on the first, second, or third energy level, or the fourth. They cannot be in between. So the next energy level can hold 32, and the final one can hold 50. I did not put 50 dots in because that's too many dots. You don't even have to do that. 32 is a lot. If you want to draw all those little dots, please do. But if you don't, I totally get it because it's a lot of dots. All right. So that is what you should draw in your notes. So if I ask you for a Bohr model, this is what I want. I want all of these rings with all of these electrons shown on them. The nucleus, you should tell me how many protons and neutrons there are. I can give you an example of this. Okay. So let's actually do that next. I'm going to pick an element. I'll show you the process. Okay, so in your notes, you'll have some stuff written here. Over here, we're going to do an example. So I'm going to choose carbon. So if we look at the periodic table, carbon has an atomic number of 6 and an atomic mass of 12.01. So in terms of protons, neutrons, and electrons, at this point you should be able to do this. It has 6 protons. Let's see, the atomic mass is 12, so minus the 6 protons is 6, so that means we must have 6 neutrons. We're going to say that this carbon is neutral, so it has the same number of protons as electrons. Electrons are negative, protons are positive, they cancel each other out, we're left with a neutral atom. Okay, so this is great. This is great information. Now let's figure out where those electrons actually are. So let's draw the model. The way I do this is I start with my nucleus, and inside the nucleus, it's hard for you guys to see. I wrote in tiny, tiny little letters, 6 protons and 6 neutrons. I put like P6 and 6N. Either way you want to do it. That's just how I ended up doing it. Okay, so that's my nucleus. Maybe I'll even draw like a purple little circle around it just to make it clear that that's the nucleus. All right. And now we need to place the electrons. So there are 6 electrons. They all want to be super close to the nucleus, but only 2 of them can be in the first shell. That's what our notes say. So I'm going to draw a circle. Okay. So that circle, that's the first orbital / shell. Okay. It can only hold 2 electrons, so let's draw those in. I like to draw them kind of far apart from each other because electrons don't actually like each other because they're negative, so they like to stay far away. All right, so we have done 2, but we need to have 6. Well, the next 4 can't be in that shell. It's just not possible. They're going to have to go up to the next level. This is the second orbital or shell. Okay. So this one can hold up to 8. However, carbon doesn't have 8 electrons. It only has 6, and we've already placed 2. So we only need to place 4 more so that the total is 6. So 1, 2, 3, 4. That is a Bohr model of carbon. It has 6 protons and 6 neutrons in the nucleus, and it has 1, 2, 3, 4, 5, 6. 6 valence electrons. So I'm going to show you or have links to other videos. So if you want some more examples, you'll be able to get those. But what I want you to do for your work, your packet work that's associated with this is this section of page 3. You're going to need to do beryllium, lithium, beryllium, boron, and helium. You can use any symbols that you want. So for example, if it were me, I might use I like something like this to be a proton, maybe something like this. And you can color code this if you want, like an N as a neutron. And, oh, nope, that's an electron. Sorry. I usually use little negative signs. And then this is a neutron. But you can choose anything you want. I have a tendency to color code. This is actually not the color code. Let me get my markers. Personally, I like electrons to be red. I just think that that's kind of cool. So there we go. I like protons to be blue. You don't have to do this, but it's just what I like to do for whatever weird reason in my brain. Protons are blue. And then I always think of neutrons as being green. I don't know why, but you'll see it in my slides. It comes up a lot. So there you go. So maybe something like that. Again, you choose whatever you want. I don't actually care. This is you. If you want to do triangles and squares and circles, whatever makes sense to you, I don't actually care. But I do want those. Now, if you look, there's a lot of space. So use all that space. Before you start drawing, I wouldn't do this in pen, I'd do it in pencil. Before you start, plan out how many orbitals you think you're going to need. I would definitely recommend for each of these problems, maybe the first thing you do is figure out how many protons, neutrons, and electrons you're going to need. And then you can draw your model just the way that I showed you how I drew mine for carbon. So that's your work for now. So you all get to that. And what we'll do for the next video is we're going to talk more about these words down here: valence and shells and orbitals, valence electrons, octet rule, and Lewis electron dot models. These are different, just so that you know, so you don't make this mistake. Bohr models go here. Electron dot models are completely different. They do not look the same. Don't even start working on this. You'll also notice I gave you way less space, and there's a reason for that. So we'll get to that in the next video. In the meantime, happy hunting to you all. Be excellent to each other, and I'll catch you for the next video.